Good morning, afternoon, or evening, cats and dogs. Today's video comes from the Numerical Expressions Guided Notes. For Math 7, it should be titled Numerical Expressions. For Pre-Algebra students, it'll be titled Lesson 1.2, Words and Expressions. But they are the same lesson with the same content and same concepts. So we'll begin with some basic definitions. The first definition is what a numerical expression is. Numerical indicates that we're talking about numbers. Expressions are things that don't contain equal signs. So a lot of times we work with equations. Here we're just working with expressions, which are things that you worked with back in elementary school when you learned basic operations. So numerical expressions contain a combination of numbers and operations, such as addition, subtraction, multiplication, and division. They're problems that we're going to solve, but we call it to evaluate. So to evaluate an expression means to find its numerical value, find its answer. I want to introduce you to that word and the phrase numerical expressions because you'll see those in some of the directions. So if it asks you to evaluate, think of it as solving that problem. Now, let's review the order of operations. The order of operations, you learn a lot of different tricks for that. Maybe PEMDAS, please excuse my dear Aunt Sally, and those work perfectly fine as well. So we start with P for PEMDAS, parentheses, but I use the word grouping symbols here because it includes more than just parentheses. It could include your normal parentheses. It could also include brackets and these double bars, which are absolute value bars. That's something we'll talk about. So when we think of parentheses, it's not just parentheses. It could include brackets and absolute value bars as well. Now within your grouping symbols, you want to make sure to follow the order of operations. So if you have more than one operation inside those grouping symbols, make sure you do multiplication and division before you do addition and subtraction, or do exponents before you do multiplication and division, and so forth. After parentheses or grouping symbols, we have our exponents. We'll talk a little bit about exponents momentarily. Then I put multiplication and division together because you don't do multiplication before you do division. You do whichever comes first from left to right. If that's multiplication, then you do multiplication. If that's division, then you want to do division first. And then addition and subtraction are also grouped, and you want to do whichever comes first from left to right. Very important things. Again, you can think of PEMDAS, please excuse my dear Aunt Sally, but keep in mind that that P parentheses includes more than just parentheses. Multiplication and division go together, as do addition and subtraction. All right, let's talk a little bit about exponents. So some key vocabulary related to exponents. First of all, if we have this is 3 to the 4th power. The big number is our base, big number, base. That's the number that's going to be multiplied. The little number is our exponent. It tells us how many times the base is used as a factor. And the entire thing, the number that can be expressed using an exponent, is called a power. In this case, 3 to the 4th power. The other thing that's really important here, and I'm going to highlight this because this is really important for us. Whoops, let me grab my highlighter. There we go, I'm out of practice. Any number raised to the 0 power is going to be equal to 1. When I ask this question in class, a lot of times students think any number to the 0 power is 0, or they think it's the number itself. So for example, they'll think 3 to the 0 power is 3, which is not the case. We'll talk about later on this year if we get a chance and we start to talk about negative exponents, which we definitely will get to in pre-algebra. When we talk about negative exponents, we'll see why anything to the 0 power is 1 and not something different. Now also down here, I'm going to highlight this in green. You must put parentheses around the base whenever the base is a negative number. That's going to be really important for us. Anytime you see things bolded or double stars or double snowflakes next to them, know that that's something that's really important. So if your base is a negative number, put it in parentheses. If your base is a fraction, you also need to put it in parentheses. And if your base itself is an expression, you'll put it in parentheses. These are some really important points for us. So let's take a look at our first set of examples. These first 8 exercise questions ask us to write each expression using exponents. So let's take a look at number 1. We've got 5 times 5 times 5 times 5 times 5 times 5 times 5. My base is 5, and since it's being used 7 times, my exponent is 7. So this will be 5 to the 7th power. Number 2, I don't have the dot to represent multiplication here or an X to represent multiplication, but the parentheses indicate that these negative 7s are being multiplied together. So our base is negative 7, and because it's negative, it has to go in parentheses. Since it occurs 4 times, it'll be negative 7 in parentheses to the 4th power. Number 3, we have 1/3 times 1/3 times 1/3. 1/3 is our base. It's going to go in parentheses. Remember we said fractions, if they are our base, must go in parentheses. Since it's used 3 times, it's 1/3 in parentheses to the 3rd power. Number 4, now we throw in some variables. Why not? This is essentially, if it's not pre-algebra or math 7, you're learning pre-algebra skills here. So our base is d in this case, and there are 5 of those, so it's d to the 5th power. Number 5, we have 3 different bases here. So a times a is a to the 2nd power. B is our next base, and there are 4 of those, so b to the 4th power. And finally, we have c to the 2nd power, also called c squared or a squared in this case. You don't need the dot for multiplication in between those variables, although you can include it, and they don't have to go in that order. We have a to the 2nd times b to the 4th times c to the 2nd power, or just a to the 2nd, b to the 4th, c to the 2nd power. All right, number 6. We have 2 different bases here. Negative 3 is our first, and it's got to go in parentheses because it's a negative number. So negative 3 to the 2nd power, followed by d to the 3rd power. We also call that d cubed. All right, 7 and 8 involve expressions with exponents. So our expression in number 7 is x minus 2. That's our base, and it has to go in parentheses to the 2nd power. Don't try to write that as x to the 2nd minus 2 to the 2nd. It's not true. You'll learn about that in algebra, what it really equals, which again is not x to the 2nd power minus 2 to the 2nd power. Number 8, our base is t plus 4, another expression, and there are 4 of those. So this will be t plus 4 in parentheses to the 4th power. All right, one thing I want to remind you of at any point in this video, if you need to pause it and go back to some of the things, feel free to do that. I'm showing you this entire lesson at once, something that's going to take us several days to do in class, but you can watch any parts of this video that you need and certainly pause it at any point as needed. All right, in fact, I want you to pause it right now because I want you to try these 4 problems on your own. So go ahead and pause the video, give these problems a try. When you're ready, restart the video and we'll go over the solutions. All right, so number 1, I hope you have 6 to the 4th power. Number 2, I hope you have negative 5 in parentheses. No parentheses, it is incorrect. Negative 5 to the 6th power. Number 3, you should have 2 bases here. So you should have b to the 3rd power, w to the 2nd power. Don't forget you can have a dot for multiplication in between those as well. Finally, number 4, I certainly hope you have u minus 8 in parentheses to the 3rd power. All right, hopefully those are pretty easy for you. Let's move ahead. Numbers 9 through 13 ask us to evaluate. There's that word evaluate. Means to solve it. Get a number answer here. Evaluate each of the following expressions, and we are doing this without calculators. I think we can handle it. Number 9, 6 to the 2nd power is 6 times 6, which of course is 36. You don't need to show work for this, but I am going to show some work for you for these problems. Number 10, 3 to the 3rd power is 3 times 3 times 3. A little bit trickier. 3 times 3 is 9. 9 times 3 is 27. So 3 cubed is 27. Again, I want to remind you, pause the video at any point as needed. Number 11, 7 to the 2nd power is 7 times 7, which is 49. Ooh, we've got some fractions here. I know that's one of our least favorite things, but let's give it a try. 1/2 to the second power is 1/2 times 1/2. It's as simple as multiplying your numerators, your top numbers, and your denominators, your bottom numbers. 1 times 1 is 1, 2 times 2 is 4. Guess what we get? 1/4. By the way, you can take the numerator, which is 1 to the second power, and your denominator, which is 2 to the second power separately, and put them together into a fraction. It also works. So if I have 1 over 3 to the third power, you could do 1 to the third over 3 to the third, which is 1 over 27, or you could multiply it out. 1 over 3 times 1 over 3 times 1 over 3. 1 times 1 times 1 is 1. 3 times 3 times 3, we already saw in number 10, is 27. All right, let's go ahead and move ahead. So now we've got to see some order of operations. So this is that PEMDAS, working with grouping symbols, followed by exponents, multiplication and division, then addition and subtraction. So it says find the value of each expression, also known as evaluate. We're going to show our work for each of these. It's really important to show your work for these problems so we can see what you're doing to get your solutions. So number 14, we have 6 plus 3 times 9. This one is done for you. I started by doing multiplication. I don't have any grouping symbols. I don't have any exponents. So we go to multiplication. I like to underline the step that I'm doing. You don't have to do that, but I think it does help you see what we're doing and in what order. So 3 times 9 is 27. Now we'll do 6 plus 27 to get a solution of 33. I do like to work down instead of across. That way I can keep track of each of my steps. It does take up quite a bit of room, but I think it does help you to see your work a little bit more clearly. Sometimes I have students who show like these little numbers above the 3 times 9, so they'll put the 27 above it and then lose track of the numbers as the problems get more complicated. Don't forget to circle or box in your answer as well. It makes it easier for you to check and for me as well. All right, let's try number 15. You may even want to try this one on your own. So I do suggest starting with multiplication because we don't have any grouping symbols. We don't have any exponents. So we'll start with 7 times 3, which is 21. Do 7 plus 21, which of course is 28. Let's take a look at number 16. 10 divided by 5 times 3. No grouping symbols, no exponents. Now we've got multiplication and division, but remember, multiplication doesn't have to come first, or doesn't have to go first. You work with whatever comes first from left to right. So as I'm reading this from left to right, I've got 10 divided by 5. I've got to start with 10 divided by 5. So let's go ahead and do that. 10 divided by 5 is 2, not 5. It's easy to make that mistake. So 10 divided by 5 is 2. Take 2 times 3. Final solution is 6. Again, multiplication and division, we do in order from left to right. All right, let's move ahead. Number 17, we've got 2 and then in parentheses, 6 plus 2 minus 4 times 3. It's our first set of grouping symbols here, so let's start with those grouping symbols. Do 6 plus 2, which is going to get us 8. Now you're going to notice that I drop the parentheses once I finish that operation, since I don't have anything left in the parentheses except the number 8. But I do need to put something between the 2 and the 8. I don't just make it the number 28. It is multiplication. If you have a number squished right next to parentheses, it means to multiply. So I did rewrite it as 2 times 8 instead of 2 parentheses 8. I think it just looks a little nicer. So we have 2 times 8 minus 4 times 3. Let's do our multiplication next. And you know what? I'm okay with you doing both sets of multiplication together. 2 times 8, of course, is 16. 4 times 3 is 12. 16 minus 12, of course, gets us a solution of 4. All right, why don't you pause the video right now, give number 18 a try. Once you're ready, restart it and we'll take a look at it. All right, hopefully you notice that number 18 is really similar to number 17. So you want to start with that 6 plus 1 to get us 7. Feel free to drop off those parentheses. You got 5 times 7 minus 3 times 3. 5 times 7, of course, is 35. 3 times 3, of course, is 9. So 35 minus 9 is going to get us 26. I really struggle sometimes with subtraction mentally, so to make it easier, I usually do something like 35 minus 10, but since I only took away 9, I want to add 1 to that. So 35 minus 10 is 25. I only subtracted 9 instead of 10, so that should be 26. All right, number 19 is a doozy. You've got several sets of grouping symbols plus parentheses that actually represent multiplication here, which can get a little complicated. So here's what I suggest you do. Start inside those brackets. Do this 13 minus 4, because you've got to follow order of operations inside grouping symbols, including parentheses and brackets. So replace 13 minus 4 with 9, and you can drop those parentheses off, not the brackets though. That's really important. Notice how I still have these brackets here. I'm going to highlight those because I still have operations inside the bracket, so I can't drop those off. That's really important. These parentheses that I'm highlighting in green right now, I did because I was left with just a number inside there. So I've got 2, my brackets, 9 plus 2 times 2. Those parentheses represent multiplication. So what I suggest you do next is 2 times 2. In fact, I may have rewritten it. Sometimes I rewrite it as 2 times 2, so you can certainly do that. 2 times 2, of course, is 4. Notice how I still have the brackets there because there's an operation inside the brackets. So now I do that last operation, and I can drop those off now. But 9 plus 4 is 13. So if you have 2 parentheses 13 or 2 brackets 13, you can certainly write that as 2 times 13. That'll also get us 26 for our solution. So be careful with this one. A lot of times students want to drop off the brackets way too early. You can't drop them off until the only thing that's left inside is a number. Like in this step here, you could drop those off and write it as 2 times 13. All right, let's move ahead. Number 20. I want you to pause the video, give number 20 a try, and again, once you're ready, restart it and we'll take a look at it. All right, so for number 20, I really hope you started with that 10 minus 6. And that, of course, is going to get us 4. Then inside your brackets, I hope you didn't drop those off. We want to do 6 times 2, because remember, multiplication comes before addition. 6 times 2 is 12, so we've got 4 plus 12 still inside those brackets. Now we'll do 4 plus 12, which is going to get us 16. And 4 times 16, that's not super easy, but if you do 2 times 16, that's 32. And doubling 32 is pretty easy. That's 64. All right, so number 21, we have our first fraction type of question here with order of operations. When you have a big fraction like this in number 21 and 22, you want to figure out what the top is, figure out what the bottom is, and then that fraction bar represents division, so divide at the end. If you were to write this from left to right as one line, you'd have to have the 16 plus 2 times 7 in parentheses and the 20 minus 5 in parentheses with a division symbol in between them. Even though there's no parentheses around the top and bottom, it's indicated by that whole top part being 16 plus 2 times 7. The whole bottom is 20 minus 5. I don't usually write it out like that in one line. I just simplify the top, simplify the bottom, and then solve from there. So what I would do first, and I'm actually going to highlight this instead of underline it, is I would do the 2 times 7 first to get 14. So I'd write this as 16 plus 14 on the top. And then I did do 20 minus 5 as well in that same step, so I'll highlight that to get 15. And that's okay to combine more than one step. Now, let's do the 16 plus 14. Let's simplify the numerator, the top of that fraction. That gets us 30. I'll just pull this all down. We've got 30 over 15. And keep in mind that's the same as 30 divided by 15. Fraction bar represents division, which is 2. Again, don't divide until the very end. Simplify it completely, then divide. All right, so number 22, we're throwing in some exponents here. We've got 4 times 3 squared in the numerator or top, 3 times 2 in the denominator. So first thing I would do is do that 3 to the second power, which is 9, not 6. I would also do the denominator as well, which is 3 times 2, which is 6. So I've got 4 times 9 on the top, 3 squared is 9, 6 on the bottom, which comes from the 3 times 2. Now, next step I would do here, which I'll highlight in green, is 4 times 9, which is 36. I've got 36 divided by 6, which is 6. Lots of 6's in this problem. All right, let's take a look at number 23. So I have 48 divided by 2 cubed times 3 plus 5. Whoa. All right, let's start with that exponent. We don't have any grouping symbols here, thank goodness. But we're going to start with this exponent here. 2 to the third power is 2 times 2 times 2, which is 8. Now I have 48 divided by 8 times 3 plus 5. Multiplication and division are next. But remember, we work left to right. So let's do 48 divided by 8, not 8 times 3. 48 divided by 8 is 6, so we have 6 times 3 plus 5. Let's go ahead and do 6 times 3 to get 18. Do 18 plus 5. Final solution is 23. All right, let's take a look at number 24. We have 12 plus 9 to the 0 power. So we're going to start with exponents here. We're going to start with 9 to the 0 power, which is 1. Don't forget, any number to the 0 power is 1. That was in our notes. So replace 9 to the 0 power with 1. 12 plus 1, of course, is going to get us 13 for our solution. So be really careful with that. All right, number 25, let's take a look at this one. So we do have grouping symbols here. In fact, we have brackets and parentheses. Let's go ahead and start inside the brackets with those parentheses. 2 plus 7 is 9. You can drop the parentheses, but not the brackets because you still have division in there. Now we'll do 9 divided by 9, which is 1. So we have 3 times 1. Notice how I replaced the brackets now with multiplication since I'm done with my operations inside the brackets. 3 times 1 minus 3. Of course, 3 times 1 is 3. And then we've got 3 minus 3, which of course is 0 for our final solution. All right, I know we're working through these pretty quickly. We've got a couple more, and then I think I've got some independent practice for you guys to try as well. Now, I put stars next to 26 and 27 because, man, oh man, these are tough. Students make mistakes on these from, Math 7, 6th grade math. I've taught some 6th grade students as well, all the way up through algebra and geometry, students making mistakes on problems like these. So let's really stress these. So let's take a look at number 26. I've got 5 and then in parentheses 8 plus 2 divided by 2 and then in parentheses 8 minus 3. So we've got to start with our grouping symbols, of course. So might as well do them both at once. 8 plus 2 and 8 minus 3. 8 plus 2, of course, is 10. 8 minus 3, of course, is 5. Now, I do suggest you rewrite 5 parentheses 10 as 5 times 10 and 2 parentheses 5 is 2 times 5. Because, again, those parentheses can get kind of confusing. Students are like, oh, it's a grouping symbol. I have to do that first. So I have to take 5 times 10 and I have to take 2 times 5. But you don't in this question. Those parentheses are not grouping symbols. They are there to represent multiplication. And remember, with multiplication and division, we work left to right. So that means we have to multiply first, then divide, then multiply again. So we need to start with 5 times 10 first, which is 50. So we have 50 divided by 2 times 5. Now do 50 divided by 2, which is 25. Take 25 times 5, and that's going to get us 125. If you get an answer of 5 for this problem, you probably did all the multiplication first to get 50 divided by 10, and then divided to get 5. But remember, multiplication and division, we do in order from left to right. So number 27, I would suggest rewriting this thing as 3 times 8 divided by 4 times 2. It'll just make things a little easier. And then we just work left to right. So start with 3 times 8 in this case, which is 24. Now do your 24 divided by 4 to get 6. And do 6 times 2 to get 12. If you end up getting, let me think through this, a solution of 3, you did all the multiplication first and then divided. Remember, multiplication and division we do in order from left to right. Really important for us. All right, so here's what I'm going to do. I'm going to have you try these independent practice problems. There are 3 of them. Pause the video, give those 3 questions a try. We'll go back to some of that reflective writing, reflective thinking, and then we'll move on with these guided notes. When you're ready with these 3 questions, start the video again. we'll take a look at the solutions. All right, so for number 1, let's take a look at this bad boy. We've got 30 divided by 5 times 3. Do 30 divided by 5 first to get 6. 6 times 3 to get us 18. I hope you got that one. Number 2, we've got 5 times 2 squared, which is going to be 5 times 4 in the numerator. 7 minus 2 in the denominator, which is 5. In our numerator again, we've got 5 times 4, which is going to get us 20. 20 divided by 5 gets us 4. Remember, with fractions, simplify the top, simplify the bottom, divide at the end. All right, number 3, don't forget, 3 parentheses 2 represents multiplication, and you have to do multiplication. In fact, let me highlight that. You've got to do 3 times 2 first here, which gets us 6. Now, don't drop off those brackets. You still have a plus sign in there. Do 8 plus 6 to get 14. Feel free to drop them off at this point and write this as 3 times 14. That will be a solution of 42. All right, we'll of course see some more practice in class. In our guided notes, you have a reflective writing section, and here it says to give an example of an expression involving multiplication and addition in which you would add first. You know multiplication comes first in order of operations, but give an example of an expression in which you would add first. Go ahead and pause the video, give that a try. So I don't know what example you came up with because obviously you're doing this on your own, but let me give you an example of something that would work here. You could have something like 6 and then in parentheses 8 plus 5. That would be an expression where you would need to add first, and the reason why is because you have the addition in parentheses. So even though multiplication typically comes first, since you have your addition in parentheses, you would do that first. So in the question where it says, why do you have to add first in this expression? More than likely, and don't go too crazy with your expressions. Sometimes I have students come to the board and they'll put these really long expressions up there and they think addition would come first, but it's not really the case. So in a problem like this, just keep it simple. The reason why we would add first in this expression is because the addition is in parentheses. So I'm going to say I would add first in this expression because the addition is in parentheses. As simple as that. Okay, you don't need to go too crazy. You don't have to write a TDA or a paragraph for this. But more than likely, you wrote an expression where the addition was in parentheses, so that's why you're going to do it first. Or within brackets, some sort of grouping symbol. Maybe you even used absolute value bars. All right, let's move ahead. All right, now we've got some evaluating algebraic expressions. Now, I know we haven't talked about algebraic expressions yet, so I'm kind of previewing a little bit of the next lessons too, but I think this is good for us to see at this point. So it asks us to evaluate each of these expressions if g equals 3, h equals 1, and m equals 9. So you're going to replace the variables with the numbers that were given for them. So number 28, when I have g to the 5th power, I'm going to replace g with 3. So I'm going to have 3 to the 5th power, and I'm still not using a calculator, and I'm still using the order of operations. So this is 3 times 3 times 3 times 3 times 3. I did do each, I'm going to highlight these. I did 3 times 3 to get 9, and I did 3 times 3 to get 9 here, and then just brought down my last 3. I did 9 times 9 next to get 81, and then did 81 times 3. And if you think 80 times 3 is going to get us 240, 1 times 3 is 3, add them together to get 243. I think this is one of the easiest ways to think through it. Now, of course, you can just multiply from left to right. 3 times 3 is 9, 9 times 3 to get 27, take 27 times 3, and then multiply that answer by 3. Whatever's going to make it a little easier for you. All right, let's take a look at 29. We've got 5 and then in parentheses g plus 1 to the 2nd power. So first things first, replace g with 3. So again, we replace g with 3. You're not going to write 3g there. We're not talking about, old school cell phones or anything. Replace g with 3. Now follow the order of operations. So we're going to do 3 plus 1 next, which is 4. So we have 5 times, you can drop the parentheses off here, 4 to the 2nd power, but you've got to do exponents first. So 4 to the second power is not 8, it is 16. Take 5 times 16 to get a solution of 80. Some of the numbers get a little higher here, but I think you can handle it. All right, let's take a look at question number 30. I just copied the directions again so we didn't lose track of those or forget which numbers we were using for which variables. All right, number 30, we've got g to the second minus m. Replace g with 3. So we have 3 to the second power minus m, which is 9. Exponents first, so we'll do 3 to the second power, which is not 6, it is 9. We've got 9 minus 9. Final solution is 0. Easy peasy. All right, number 31 looks a lot like question number 29, but we have another variable in there. Replace m with 9, replace h with 1. Start inside your parentheses, so we're going to do 1 plus 1 to get 2. So I have 9 times 2 squared. Of course, do your exponents next. 2 squared is 4. So we'll do 9 times 4. Final solution is 36. All right, let's take a look at number 32. Pretty similar to the last problem that we had. We are going to replace h with 1. So we have 4 and then in parentheses, not 21, but 2 times 1. Anytime you have a number squished next to a variable, it means to multiply. Inside your parentheses, follow those order of operations. 2 times 1, of course, is 2. So I have 4, and I keep my parentheses here because I still have an operation in there. So we have 2 plus 1 inside the parentheses. 2 plus 1, of course, is going to get us 3. So we take 4 times 3 squared. 3 squared is 9. We're going to see it so many times. And 4 times 9, of course, is 36. We're not going to get that many 36s all the time, but we do see that number quite a bit. All right, number 33, m to the 0 power plus 9. M is 9. In fact, it doesn't matter what variable we use there because anything to the 0 power is 1. So we get 1 plus 9, which of course is 10. Again, anything to the 0 power is 1. All right, so I'm going to skip over the word splash. You might have seen that scrolling by. This is something we typically do in class to look at operations that are used, or I should say phrases that are used for operations. So the word quotient is used for division. We could say divided by, we could say the quotient of, the word difference, which is used for subtraction, instead of maybe just the word minus. That's all summarized in your guided notes. So I'm not going to take time in this video to do the word splash. We would, though, in class do that. So some words that represent addition that I want to stress to you, because we're now going to be writing some numerical expressions. Words that represent addition include plus, sum, which you've probably seen before, more than, and increased by. For subtraction, we use the words minus, difference. Be careful because students see the letter D and they think division. Difference is for subtraction. Less, I'm going to skip this box for now, and decreased by. Less than, fewer than, shorter than, for example, if you see those, you switch the order around. And by that, I mean, if you look at example 3, 5 less than 12 means to take 5 away from 12. So instead of doing 5 minus 12, we flip-flop the numbers. So you put the 12 first and the 5 second. Now, sometimes I have students who are like, well, the bigger number has to come first. Hey, we're going to see negative numbers. The bigger number doesn't have to come first. But if you say 5 less than 12, it means to take 5 away from 12. Take a quick look, though, at example 2. It uses the word less, not less than. So 8 less 3 means I've got 8. Less 3 means to take 3 away from that. So you keep the order the same there. So if you see like less than, fewer than, shorter than, switch that order around. For multiplication, we use words like times, product, which is often forgotten, multiplied by, and sometimes the word of is used in word problems, or when we start talking a little bit about percent problems. You'll see those later on this year. Finally, division, we use the words divided by and quotient for that. All right, let's go into our exercise questions. Oh, I didn't realize I had that down there. It's actually here as well. So these questions ask us to write a numerical expression for each verbal phrase. You don't have to answer it, just write an expression. So in number 34, I have 25 increased by 6. And I'm going to highlight some key words here. Increased by means addition, so we'll write 25 plus 6. Number 35, 11 less than 20. Less than indicates subtraction, but if I say 11 less than 20, it means I'm taking 11 away from 20. My correct expression is 20 minus 11. Number 36, the quotient of 64 and 8. The word quotient means division. I wrote it like this, 64 divided by 8. You can use the slash for division. You can write it as a fraction. You can even write it how you did long division back in elementary school. We don't typically see that here, but this is just one way to write quotient. Number 37, the product of 7 and 12. Product means multiplication, so 7 times 12. You will learn later on this chapter also that some operations are commutative, meaning you can do them in whatever order. So for example, with addition and multiplication, you could switch the order around. Number 38, 40 less 6. Less means subtraction, but we don't switch the order around. If you have 40, less 6 means 40 minus 6. All right, we can't make all these obvious. So number 39, here's where it gets a little bit trickier. The total cost of 8 books at $5 each. One way to write this is 8 times 5. It doesn't tell you its multiplication, but you have 8 books, they're $5 a piece. To find the total cost, take 8 times 5. No need for a symbol, a dollar sign on that, or labels or anything like that. Just 8 times 5 works. I have seen students add 5 8 times as well. That also works. Number 40, the total amount of apps. If Isabel has 6 and Lauren has 4, my question is, why don't they have more apps? But in this case, total represents addition. So 4 plus 6 or 6 plus 4. Number 41, the number of cards left if 16 of 52 have been dealt out to a group of people. Maybe it's 2 people playing Uno, for example. This is going to be subtraction. When we're talking about what's left, often that means subtraction. So we can write this as 52 minus 16. Finally, number 42, the number of weeks until Christmas break, if break is 42 days away. So you have to know how many days are in a week here. So that's not given, it's not quite as obvious. But if you take 42 divided by 7, that would get you an answer of 6, which makes sense. It would be 6 weeks left. So 42 divided by 7. All right, moving right along, we're going to move on to some more complicated word problems here. I definitely want to get through these as quickly as we can because I know this video is pretty long if you're watching it all at once. But again, feel free to only watch the parts you need. So number 43, it says a cell phone company charges $20 per month and 10 cents for each call made or received. I know it's not completely real life related, but we'll get to those. Letter A or part A. Write an expression to find the cost for 44 calls during 1 month. So let's highlight our important information. We've got $20 per month, and keep in mind this is in a 1 month period, so we're going to pay $20. And, or in addition, 10 cents for each call made or received, and we made 44 calls. So that indicates that I'm going to multiply the 10 cents by 44, and I need to add on that $20. So one way to write this is 20 plus 0.10 times 44. Could you do 0.10 times 44 plus 20? Sure. Now, part B asks us to evaluate. That means get a number answer here. So if I take 0.10 times 44, that is 1/10 of 44, which is 4.4. 20 plus 4.4 is 24.4, which is $24.40. Letter C. Make a table showing the cost for 50, 60, 70, and 80 calls. So we've got the table set up. We've got to find those costs. For 50 calls, that's going to be 20 plus 0.10 times 50. For 60, it's going to be 20 plus 0.10 times 60. 70, it's going to be 20 plus 0.10 times 70. And finally, 80, that's going to be 20 plus 0.10 times 80. 0.10 times 50 is 1/10 of 50. That's 5. 20 plus 5 is $25. 0.10 times 60 is 1/10 of 60, which is 6. 20 plus 6 is 26. You'll notice a pattern here as well. 0.10 times 70 is 1/10 of 70, or 7. Add that to 20 to get 27. And finally for 80, 1/10 of 80 is 8, plus 20 is 28. You will see a pattern with these numbers because it's really a linear equation type of deal, something we'll see later on this year. Plus we have a pattern in the number of calls that we chose. If those are random numbers, you might not see a pattern, or you would not see a pattern, I should say. All right, number 44 is a little bit trickier. Often we have similar problems. Sometimes they get a little bit more difficult. So number 44, it says a taxi charges $4 for the first mile and $2 for each additional mile. Write an expression to find the cost for a 10-mile trip. Now, it's really tempting to say, okay, it's $4 for the first mile, so I've got 4, plus then we've got $2 for each additional mile, to take 2 times 10. But keep in mind our first mile is the one that's $4, and every additional mile, which is our other 9 miles, it's going to be $2. So you want to start with 4 plus, and then $2 times 9 miles, because we have 9 additional miles on top of that first mile. Let's evaluate this expression. So we'll do 4 plus 2 times 9. Don't forget order of operations. You've got to do 2 times 9 first, which is 18. 4 plus 18, of course, is 22. If you do not follow order of operations, you're going to get a much higher cost because 4 plus 2 is 6. 6 times 9 is 54. So be careful. This should be $22. I should probably circle my final solution. There we go. Letter C, make a table showing the cost for a 20, 30, 40, and 50-mile trip. So our first section is going to be the number of miles, and we've got 20, whoops, move that out of the way, 20, 30, 40, and 50. In the center, we'll put our expressions and, of course, our total cost. So for the 20 miles, I've got 4 plus 2 times 19, since it's 19 additional miles on top of the first mile. For 30 miles, it's 4 plus 2 times 29. For 40, it's 4 plus 2 times 39. And for 50, it's 4 plus 2 times 49. Now again, I'm going through this quickly because I don't want to make the video like 2 hours long. Feel free to pause at any point as needed. All right, so we've got 2 times 19 in the 20 miles, which is 38. 38 plus 4 is 42. And you'll notice a pattern here as well, since we have our pattern in our number of miles. 2 times 29 is 58. 58 plus 4 is 62. 2 times 39 is 78. 78 plus 4 is 82. Now, I'm very practiced with doing this math, so it might take you a little longer, might be a little harder, and that's okay. Some people are really good at mental math. Others, not as much, and that's okay. I really have to write everything down. I'm one of those people that struggles a bit with mental math. So if you're one of those people too, that's okay. 2 times 49 is going to get us 98. 98 plus 4 is 102. You notice a pattern here in your total cost as well. All right, next question. We're getting really close to the end. It says the Simpson family visited a local museum one summer afternoon. Ticket prices are shown below. Write an expression that can be used to calculate the total price for 2 adult tickets, 2 student tickets, 1 child ticket, and 1 senior citizen ticket. Now, I want to let you know, these are going to be really similar to problems we'll see throughout this unit that you'll see on a review sheet, and that means you'll also see problems like this on your test as well. So be ready to see a problem just like this on the review sheet and then the test. So we've got 2 adult tickets at $17.50. So that's $17.50 times 2. That's for our 2 adults. Let me highlight that for us. So this is for our 2 adults. Plus, we have 2 students at $9 a piece. So that's going to be 9 times 2. Could you switch the order around and do 2 times 9? Absolutely. And then finally we have, not finally, sorry, we've got 1 child ticket, which is $6. So you can just do plus 6 at this point. Highlight that. And then we have 1 senior citizen ticket, and that is $7, so you can do just plus 7. Now, could you do 6 times 1 and 7 times 1? Sure. It's not necessary to do that, though, and it doesn't actually ask you to evaluate it. It just says, write an expression. We did it. We're done. All right, not done with this video though yet. We've got one more question, a few independent practice problems, and then we're done. So number 46, it says Janine and Joseph were asked to evaluate an expression. Their work is shown below. Who is correct? And explain your reasoning. You'll see problems like this quite a bit. We do see error analysis questions pretty often here. So why don't you take a look at their work, see if you can figure out who is correct. So I hope that you recognize that Joseph is correct. Now you're going to notice my explanation is very long here. You might not need quite as much as I have here, but Joseph is correct. The parentheses in the expression that both are given represent multiplication. So in an expression involving both multiplication and division, keep in mind you need to work left to right, and I do suggest, neither of them did this, but I do suggest rewriting those parentheses as multiplication, like 5 times 6, 3 times 2. So you should be working left to right, which is what Joseph did. He worked left to right. He did multiplication, then division, then finished with multiplication. And he divided at the end, Janine did all the multiplication and then divided at the end, which is incorrect. So again, multiplication and division, we work left to right. All right, last thing for you, I want you to give these 4 questions a try. Pause the video. You're writing some numerical expressions here. When you're ready, restart it and we'll go through the solutions. All right, we're almost done here. So number 1, we've got 18 less 9. Hopefully you wrote 18 minus 9. It didn't switch the order around. Less than you do, less you do not. The quotient of 54 and 6 is division, so you'll have 54 divided by 6. Number 3, the product of 10 and 13 is 10 times 13, and 7 less than 11 is 11 minus 7, not 7 minus 11. Remember, if we see less than, we've got to switch that order around. All right, thanks for listening, and have a great day.